Hello everyone, welcome to video lecture series on programming with C. In this session, we'll study about arrays in C. An array is a data structure which allows us to store collections of data items of similar data type. These elements are stored in contiguous memory locations. Generally, we use arrays when we want to work with large quantities of data. We cannot use single variables. In such cases, arrays are useful. You can have an array of primitive data types such as integer, float, or any other data type. At the same time, you can have an array of derived data types as well. Let's see how to create an array and use it. To declare an array, we have to specify the data type, then the array name, wherein it is a valid identifier, say data, followed by square brackets, and in the square brackets you have to specify the size. Let's say 5. What does it mean? It means that you can store 5 elements of integer data type in this particular array. This is known as array declaration. We can declare an array and initialize it also at the same time. To do this, we have to specify integer, say data1 equal to, in curly brackets, the values, say 2, 4, 7. What this line does is it creates an array of 3 elements with values 2, 4 and 7. This is how we can create an array in C. The size of array is fixed in nature. Once allocated, we cannot change it. We can access the elements of the array using the square brackets or index operator. Let's say I want to access the element at 0th location. I can do it using data1 of 0. If we compile and run this code, what we'll get is the element at 0th location, which is 2. The array indexing always starts from 0 and the index of last element is the number of elements minus 1. Let's see now how memory is allocated for arrays. This is how we declare an array. Int data of 5. What happens after this is a contiguous block of memory locations is allocated like this, and a variable with name data is created. The variable data points to the first memory location from the array of consecutive memory locations. To access each element at the array, we have to use index. The array indexing starts from 0, whereas the index is size of array minus 1. We can access the element at a specific location using data of 1 equal to 20. This line will assign a value of 20 to the first element. Since the array indexing starts from 0, the first element is this. This is the first element. And we can access the value and assign it to another variable using, say, int x is equal to data of 1. The memory is allocated contiguously for array. And if you see, to store each element's value, it is taking 4 bytes. Since the data type of the array is int. So, to summarize, the length of array is 5, the start index is 0, and the end index is 4. Let's experiment more with arrays. Let's have a look at this particular array. Here we have 5 elements and the values of each of the elements are 3, 4, 5, 7, 9. How it would look in RAM? It would look like this, wherein contiguous block of memory is allocated. Now let's experiment with manipulation of array elements and access of them. So first of all, I'm printing, say, %x, and I'm directly printing the value of r. What it does, if we compile and run the code, it will print some hexadecimal address, and this is the address of the first memory location from the array of consecutive memory locations where your array is stored. It means that array is a pointer variable, and if we directly print the value of r variable, then in that case what happens is we get the address of first memory location. Now let's print %d, and see now what I'm printing is r of 0. If I compile and run the code, the second line will give me the value 3. It means that the subscript operator is accessing the value at 0th location. Now let's say I'm printing *r. As we have discussed in previous session, asterisk is used as a dereference operator. What r stores? R stores the address of the first memory location, whereas the *r, let's see what it prints. It prints the value at the 0th location or the first location. Now what does it mean? If you look at these two statements, they are giving us the same output. It means that subscript operator acts as a dereference operator. Subscript operator acts as a dereference operator, and it dereferences the value at the specified index. Let's experiment more. If I print r of 1, what I'll get the value, the next value, which is 4. Now, if you look at this particular example, what exactly the compiler is doing when I specify r of, say, x equal to, what it is doing is it is taking the base address plus x, and then it is dereferencing this particular value. It means that this is similar to asterisk r plus 0. This is similar to asterisk r plus 1. It means that the subscript operator is dereference operator, and it is adding the value of index to the base array address and dereferencing the value at that particular position. For example, if the base address for r is 2000, r plus 0 would be 2000, and the subscript value will return value at 2000 location, whereas r of 1 will add 4, since size of integer is 4 bytes, to 2000, and what we will get is 2004, and the subscript operator will print the value at 2004. This is how array index works, or the subscript operator works. A very important question that may come to your mind: why array indexing starts from 0 and not 1? Let's say I want to access r of 1. If I access r of 1, actually the subscript operator, what it is doing? It is dereferencing using r plus 1, that is 2000 plus 4. Now 2000 is the base address of R as we have seen earlier, and 4 because it's integer and size of integer is 4. And that's why the total address would be asterisk 2004, which is dereferencing the value at 2004, which is 4. This is how the subscript operator works. Let's say our indexing starts from 1. It doesn't start from 0. What will happen? In that case, we will never use the address at 0th location, because with the subscript operator strategy, it will add 1 to the base address. Let's say 2000 plus 1, 2004, and we will never use the address 2000. So to use the base address to store the element, what is done? The array indexing starts from 0. Let's use the post increment operator with AR. Now as we know that AR stores the base address, if I specify AR++, what would happen? If we try to compile this particular code, it generates an error. What does it mean? It means that we cannot increment the address stored in an array variable. In other words, the addresses of AR variable or array variable are constants. They cannot be changed once assigned. Now, if I specify, say, printf %x AR+1, what will happen now? If I compile and run the code, actually it is giving the second location's address. See now, ++ operator is trying to change the value of AR variable itself, but AR+1 operator is not assigning the value, it's just fetching the next value. So the assignment or the increment operator is not possible, but we can fetch the values of consecutive addresses using plus operator. So we can use plus operator with array symbol. Now if I just change this to, say, for example, asterisk R and +1. If I compile and run this particular code, what will happen? It will print the value of 4, but actually there is a value 3 at 0th location. So asterisk R will give me 0th location value, and to that value I am adding 1. That's why I am getting 4 as my output. Now we'll try to assign one more time asterisk R++. If we compile this particular code, is it working? Yes. And if I compile and run, what would be the output I'll get? I'll get 3 because I have used post increment. Again, here I am working with value, not with addresses. So this is a legal statement. Now I have declared a pointer variable ptr, and to it I am assigning the variable r. Will it work? Yes, it will work because r is a pointer variable, and now both r and ptr, they are pointing to the same memory location, that is the 0th address of r array. Now let's try to assign one array directly to another array. Say I am creating another array r1 equal to r. If we compile this particular code, it will give an error. That is, we cannot assign one array directly to another array. If we want to copy an array from one array into another array, we have to explicitly copy each element at a time. So we cannot assign one array to another array. If we print the size of an array using size of operator like this, this will print the size of the array. Now the size of array in this case printed would be 20. Why 20? Actually the array consists of 5 elements and each of the element is of type integer, which requires 4 bytes. So total it would be 4 into 5, that is 20. If we specify size of array of say 1, then in that case it will print individual elements size, which is 4 bytes. So the printing the size of array is 20, whereas individual elements value would be 4. All these types of arrays are known as one-dimensional arrays. Now, there are many benefits of arrays. Arrays allow us to store collection of elements. Arrays allow us to access these elements randomly. It stores the elements in contiguous memory locations. It stores the elements sequentially. We can process data faster with arrays. That's it for the arrays. Thank you everyone.